The experiment often consists of repeated trials, each with two possible outcomes that may be labeled a success or a failure, and each trial is called a Bernoulli trial. Bernoulli trial. The Bernoulli process properties. So we are saying that the experiment consists of repeated trials, and each trial has an outcome or a success or a what? Or a failure. The probability of success P remains constant from trial to what? To trial. And then the repeated trials are what? Are independent of each other. The number x of success in n Bernoulli trials is called a binomial random variable if the probability distribution is defined by this function n combination x p to power x q to power n minus x, where n is the number of trial, x is the number of success, p is the probability of success, q is the probability of failure. The mean and variance is given by mu is equal to np, and the variance is given by np and what? Times q. Multinomial distribution. Remember, the binomial experiment has two outcomes, a success or a failure. Whereas when we have more than two levels of outcomes, and this experiment is repeatedly done, then the distribution that we shall get is called a multinomial distribution. If a given trial can result in the k outcomes, which is defined by epsilon 1, epsilon 2, epsilon 3 up to epsilon k, with their probabilities equal to p1, p2 up to pk, then the probability distribution of the random variable x1, x2 up to xk represent the number of occurrences for epsilon 1, epsilon 2, epsilon 3 and up to epsilon k in n independent trial is f of x1, x2 up to xk, comma, with the probability of p1, p2 up to pk with n trials is given by the probability distribution function as this one here, which is equal to n combination f of x1, x2 up to xk, p1 to power x1 plus p2 times p2 to power x2 times pk to power what? Xk, where the sum of I equals from 1 to k of xi should be equal to what? To n. The multinomial distribution derives its name from the fact that the terms of the multinomial expansion p1 plus p2 plus up to pk to power n correspond to all the possible values of f of x1, x2 up to xk, p1, p2 up to pk, n. What is hypergeometric distribution? A hypergeometric distribution is a sampling method. The difference is on the sampling what? Is on the sampling method. If you are to compare it with the what? With the binomial what? Distribution. It does not require independence, okay? Assumption, and sampling is done without replacement. It's applied in acceptance, sampling, electronic testing, and quality what? Assurance. In other words, when you look at the binomial distribution, it has two options, either a success or what? A failure. And the way a binomial distribution is sampled is different from the way the hypergeometric distribution is sampled. In a hypergeometric distribution, the sampling is with replacement, whereas in a binomial distribution, the sampling is without replacement. So that is where the difference is between the binomial distribution and the what? And the hypergeometric distribution. For example, what is the probability of selecting 5 cards from 52 consisting of 3 red and 2 black cards? The solution is as follows. They are asking us the probability of selecting 5 cards from 52, of which 3 are red and 2 are black. So we have the 3 red and the 2 black. But for the 3 red, we have to get it out of the number of ways we can pick 3 red from 26 is 26 combination what? Combination 3. Whereas the remaining 2, we can also get it from 26 combination what? Combination 2. And we know that there are 52 cards. So we can get it out, we can pick 5 from 52 in 52 combination 5 ways, which is equal to 0.385 what? 51. Remember, we have selected 5 cards from 52, of which there were 3 red and 2 what? And 2 black. Properties. A random sample of size n is selected without replacement from n items. Of the n items, k may be classified as success and n minus k can be classified as failure. If a random sample is selected without replacement, okay? Without replacement, remember that the hypergeometric distribution is done without what? Replacement. So whereas the binomial distribution is done with replacement. So if k may be classified as a success, then the remaining n minus k can be classified as a failure because the sampling has been done without a replacement. The probability distribution, therefore, of a hypergeometric probability distribution is given by h x capital N, which is the small n, and what? And k, where it is given by k combination x and n minus k combination n small n minus x divided by capital N combination what? Small n. For example, let lots of 40 components each are deemed unacceptable if they contain 3 or more defectives, okay? The procedure for sampling a lot is to select 5 components at random and to reject the lot if the defective is found. What is the probability that exactly 1 defective is found in the sample if there are 3 defectives in the entire what? In the entire lot? Solution. Using the hypergeometric distribution, we have our small n is equal to 5. Remember, the procedure for sampling a lot is to select 5 components. So 5 has been selected, and our capital N is 40 out of the 40 components. Okay? Of these 5 selected at random, and it is rejected if it is found defective. So the question is, what is the probability that exactly one defective is found? So let x be the number of what? Defective. So if x is equal to 1, then we shall our k is going to be equal to 3, because there are 3 or more defectives. Okay, our k is equal to 3, which is the number of defectives, and 1 is the number of defectives to be rejected if it is found in the what? In the experiment. So we find the probability of obtaining one defective to be probability of x equals to 1, capital N equals to 40, small n equals to 5, and k equals to 3. So remember, out of the 3 defective, we are saying we are selecting 1, and we do this in 3 combination 1 ways, and there are 40 components. So when we remove the 3, we are left with 37 what? Components. And you should know that there are 5 which has been sampled, so the remaining 4 will be selected out of the 37, and then we have to divide by the total number of possible ways of selecting 5 components out of the 40, which is equal to 40 combination 5, which is equal to 0.3111. Once again, this is not desirable since it detects a bad lot of 3 defectives only but 30% of the time. The mean and variance of a hypergeometric distribution is given by as follows. The mean mu is equal to n times k over what? Over capital N. And the variance sigma squared is equal to capital N minus small n over capital N minus 1 times small n times k over capital N into 1 minus k over what? Over n. Remember, they can ask you a question that they give you an experiment which is following a hypergeometric distribution, and they may ask you to get the mean and the variance of the what? Of the distribution. A binomial distribution can be used to approximate the hypergeometric distribution when n is small compared to infinity. So when n is small, we can approximate the hypergeometric distribution with the what? With a binomial distribution. As a rule, the approximation is good when the ratio of n to small n to capital N is less than or equal to 0.05. So if you get this ratio of n, small n to and capital N equals to less than or equal to 0.05, you can approximate the hypergeometric distribution with the what? With the binomial distribution. If n items can be partitioned in k cells, where A1 is comma A2 up to AK are the different cells, with small a1, a2, ak as elements respectively, then the probability distribution of the random variable x1, x2 up to xk, representing the number of elements selected in a1, a2, is a random sample of size n if the probability